Okay, so one step further, if we use the stronger assumption that the errors are IID normal, 0 sigma squared, then we obtain, in addition, so we already have the mean and the variance and the covariance of these two estimates, but we also have that they have normal distributions if the errors have normal distributions. Okay? So if we're willing, or if we feel like imposing that extra assumption of normality of errors, then what we get out of it is normality of our estimators. Okay? Okay, one loose end. Note that the distributions of beta naught hat and beta 1 hat are functions of sigma squared. That is the error variance. We often don't know the error variance. Why would we know the error variance? So we estimate it. Okay? And we're going to use a different estimator than estimators we've seen before. So we're going to use an estimator that's equal to 1 over n minus 2 times the sum of the residual squared. Okay? And this estimator, it turns out, is unbiased for sigma squared in the linear model. That's why we use it. Why the minus 2 in the denominator? Well, it's because we're estimating two parameters. Do you remember our unbiased estimator for the variance when we were just estimating the mean had an n minus 1 in the denominator? Well, here we need the n minus 2 because we're estimating two parameters, a beta naught and a beta 1, and it turns out that that's what we need for sigma squared to be unbiased. Okay, so now I want to ask you to think back to when we were doing univariate inference and we replaced an unknown variance with an estimate of the variance. So we had a sample mean, and the sample mean had a normal distribution, but we didn't know the variance. The standardized sample mean had a standard normal distribution, but we actually didn't know what the variance was, and we replaced an estimate for the variance. What happened? You guys remember? That's what happened. T-distribution, right? Okay, well, the same thing's going to happen here. We'll talk, I won't talk about sort of t-tests in the context of linear regression today. I should be able to get to them next time. But basically, just to give you a little bit of a preview, the same thing's going to happen here. We have, under the assumption of normal errors, we have that beta naught hat and beta 1 hat have normal distributions, but we don't know what their variance is. We're going to have to use an estimated variance instead, typically. And so that's where the sort of t-test in the linear regression context comes from. Okay?